Okay, so morning or afternoon or whatever time it is. Today is day 3 in the probability unit, and we're going to be looking. Last day you looked at it, doing some trials, and then rolling a die, doing some trials, up to 100 of them or maybe more, and seeing if the theoretical probability, which I gave you, 1 out of 6, for that 6-sided die roll, was the same as if you did a bunch of trials and then calculated. What you should have found out was probably that the more you did, the better it got, or closer it got, but probably where the values weren't exactly the same. They were slightly different. And the more you did, hopefully the closer you got. Maybe not. Maybe you got worse. I don't know. Depends on the experiment you did. We did a coin flip, we did a dice roll, and we did the combination of the two together, where the probability of that was 1 in 12. So what we're going to look at today is how do we calculate theoretical probability of events occurring? Drawing things, drawing cards, drawing things out of a bag, rolling die, rolling 2-sided die will be one that we look at. And we'll look at a few different problems. Now, your book doesn't do a very good job of this in terms of practice work. So I will probably just give you some practice work in the video today to do and get you to pause it, try it, and then we'll go through it kind of thing. So there won't be any sheets or anything like that to worry about today. We'll just kind of work through it in the video. And the video will be a little bit longer as a result because we'll do some questions in the same time that we're doing the video. I'll just get you to pause it and then try them and then unpause it and then we'll kind of do them. Okay, so let's start off with the formula. Okay, so what is the formula for theoretical probability? So, and we're going to call it probability from here on out, but we're going to be specifically talking about theoretical probability. So if I say the word probability, you know that I'm talking about theoretical probability. So the formula for theoretical probability of an event spell that right, is, okay, so we'll get it out here. And it's mostly a word one, so it's a fraction, obviously, because we're going to be doing some dividing. Whoops. Get my sheet here. There's my notes on it here. Okay, so what it is equal to the number of outcomes favorable to the event over the number of possible outcomes of the event. So that it's going to be equal to the number of favorable outcomes divided by the total number of outcomes. For an event. Okay. So that's basically pretty easy to do. And it'll give you a decimal number. You can express it as a fraction. You can express it as a percentage. So let's look at some real examples here. Okay. Rolling a die. Okay. So I might ask, what is the probability of rolling a number, or let's say an even number, on a 6-sided die? Question mark. Okay, so when we're doing that, the total number of sides on a 6-sided die are 6. There are 6 numbers. So we have the total outcomes Let's do blue here. Okay, so the total outcomes that we could get are 1, 2, 3, 4, 5, or 6. And the favorable ones we'll circle in green. So I'm going to do an even number. So this is even, this is even, and this is even. So our formula is the number of favorable over the total number. So the probability equals, we'll say probability, we'll just go with P. And we'll say that we have 3 favorable over 6 total. Okay, this is equal to 1/2 if we reduce it, or if we write it as a decimal, 0.5, or if we write it as a percentage, 50%. Okay, typically I just leave it as a decimal, but I think the book sometimes uses percentages. Okay, so we can write it as a fraction, a decimal, or a percent. So favorable over unfavorable, or sorry, favorable over total number of outcomes. Okay, so let's do another example here. Okay, what is the probability of rolling a number less than less than 4, or well, let's go less than less than 5 on a 6-sided die. Okay, you can try that one and unpause it. Then you wrote it down, and then I'll be going over it. Okay. All right, so if we were doing that one, probability is going to be number less than 5. So that would be 4, 3, 2, and 1. So our probability, our favorable numbers would be less than 5, 4, 3, 2, and 1. That'd be 4. And their total on the 6-sided die are 6. So that would be 2/3 as fraction form, or 0.67 as decimal form, or 67% as percentage form. Okay, so that is just a simple 6-sided die type question. Okay, sometimes they do some drawing questions, like drawing marbles out of a bag or drawing tickets out of a drum, just kind of like bingo, something like that. So let's do one like that in another example. So let's do example 3. Now, like I said, the book doesn't do a very good job of this. They don't even cover it that well. Okay, so we're going to probably just kind of do it through our notes here. Okay, so this will be example 3. In a bag, there are 4 blue, 5 green, 2 yellow, and let's go, let's use a different number here. Let's use 8 orange marbles. Oops, spell it right. Okay, so that's what's inside the bag. Okay, so my question is, what is your the probability down here. Of drawing a green marble from the bag. Question mark. Okay, so let's put this as A. Let's do a couple on this one. So let's go A. I'll just. What is the probability of drawing? So we have to look at what is the total number of marbles and how many of them are green. So we got to do our total. Its probability is going to be, I like to write the formula as favorable over total. So that's one way you can write your formula rather than writing out the whole words that we had at the top there. So we can count the favorable number. We have 5 total green marbles. And we have a total of 4 plus 5. We have to count those as well. That's 9. And 2 more, that's 11. And 8 more, that's 19. Okay, we can't reduce that. So if we wanted that as a decimal, we would divide out 5 divided by 19. So we could do that on our calculator. Okay, that gives us a decimal number of 0.263 with a little bit after. So if we just go 0.263, and if we change that to percentage by multiplying by 100, we could say it's 26.3% that you're going to get a green marble. Okay, so let's go with the one thing they'll try to do is they'll try to trick you sometimes, and they'll throw in a word like not. So let's do one like that. So what is the probability of drawing, or not, let's go, not drawing a yellow marble from the bag? Okay, so this is called, sometimes in later years we call this a complementary event, but at this particular time we're just going to do the calculation for it. So the calculation is going to be, probability is going to be favorable over total. Now the favorable ones are anything that's not yellow. Anything that's not yellow. 9 and 8, that's 17. And the total never changed. It's the same number of marbles over 19. Okay, so 17 divided by 19, that's going to give us decimal 895. Or 89.5%. Okay. Okay, they could use the word or as well in there, or and. And I'll show you how the and one works later in the video because it's a little trickier. Okay, so what is the probability of drawing a yellow or green marble? You can try that one out. Obviously, you're going to count yellow and green marbles. Okay, so if we're doing this one, probability is equal to favorable over total. So it's going to still be over the same total. The only time the total is going to change is if you do double events, like 2 draws or something like that. And that gets a lot more complex. We may touch on that if we have time. Okay, so favorable is yellow or green. Yellow or green. 5 and 2. That's 7 over 19. Okay, so if we do the decimal on that one, that's decimal 368 or 36.8%. Okay, so that's drawing out of a bag in example 3. In example 4, let's do some cards. Okay, with or without jokers in them. We'll say without jokers. So we have to know what is in a deck of cards. In a deck of cards, we have diamonds, spades, clubs, and hearts. Okay, and you have 3 face cards, and you have 1 to 10, or the aces of the 1, in those suits. And you also have 52 cards. And some, if you say without jokers, it's 52 cards. And that's what we're going to assume. So let's do an example using cards. And then we'll do the hardest example that we do in grade 9, and that's two 6-sided die rolling together. Okay. So in example number 4, okay, from a standard deck of cards, that means no jokers. Find the probability of drawing from the deck A, an ace, and we'll just do them underneath. So B, a face card, C, throw one in with a heart, okay. And let's throw a real tricky one in there in our last one. A face card or a heart. There's a tricky one for us. Okay, so if we're doing these 4 examples, we'll have to count them out. So an ace, we know that there's 4 aces in a deck of 52. So we're going to use this same formula all the time. Probability favorable over total. 4 out of 52. If we divide that out, it's 1 out of 13. And if we write that 1 divided by 13 as a decimal, it's 0.77 or 7.7%. Okay, a face card, we have a jack, queen, and a king of hearts, spades, diamonds, and clubs. So there's 12 out of 52. Okay, now if we reduce that, we can take out a 4 from each. This will be 3 out of 13, which if you want to do that in decimal form, you could just take your 12 divided by 52 if you wanted and get 0.231. 0.231. And that as a percentage would be 23.7%. 0.1%. Okay, a heart. Well, there's 13 hearts out of 52, which if you divide that out, it's 0.25, which would be 25%. Okay, obviously you could reduce this one, I guess, down to 1 out of 4. Because 13 goes into 52 4 times. Now here's my tricky one. A face card or a heart. Now there's 12 face cards and there's 13 hearts, but 3 of those face cards are hearts. So we can't count them twice. So we've got 13 hearts. Okay? Including the Jack, Queen, and King of hearts, which we don't want to count again. But then what do we have left for face cards that we haven't drawn? Plus, we've got the Jack, Queen, and King of diamonds. Okay, and we plus the Jack, Queen, and King of spades. Oh, oops, run out of space on the side. And plus the Jack, Queen, and King of clubs. So we've got 9 extra, because we don't want to count those. We count those 13 hearts plus 9 extra. So that's 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we have 22 favorable draws out of our 52. Okay, that's 11 out of 26 if we reduce it. Sorry about the chats that are coming in there. Don't worry about them. Okay, so if we divide 11 divided by 26, I get decimal 423. Oop. I must be doing something wrong here. Okay. I must have been pushing the old button there. Okay, sorry about that. Okay, so if we do 11 over 26, we get the decimal 4. Zero decimal 4, 2, 3, which is 42.3%. Okay, and I just got to fix my, apparently I was pushing my chat app here, so I got to fix that. So I'm just going to pause for a sec. Hey, sorry about that. We're just converting over to chat rather than Hangouts. That's what everybody was talking about there. Okay, so there's some examples. So sometimes it's a little bit tricky. You have to count, make sure you don't double count something when they put an or in there. So ors can be tricky. Okay, the last type of probability app that I'm going to, or app probability question is a 6-sided roll. A 6-sided roll, when you take 2 6-sided die rolls and you roll them, you have a chance of getting a 1 to 6 on one die and a 1 to 6 on the other die. So that gives you a 6 by 6 grid. So when you're working with 2 6-sided die, we like to have a grid made. So it's a good idea to have a grid to look at. So let's look at that on the next page here. Okay, so this is example 5, and this would be 2 6-sided dice being rolled. We'll just say it rolled. Okay, so our sample size, our possible be shown in a grid, we'll say. Okay, and so I'm going to write my grid out here. I'm going to make mine 6 by 6. Okay, so I'm going to make it a little bit bigger. So I should use a straight line tool here to make it a little easier. So let's just delete that one and use a straight line tool here. I could make a grid, but I'm just going to make it so that I can put them all on here. This is going to be my field of possible rolls. So one die is going to be on the side here. So 1, 2, 3, 4, 5, 6. So I should make this bigger. Okay, and then I'm going to have here 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 6. So there's all my possible rolls. So I can get on the, if we're doing totals on the die, let's do the first die in here. Let's just say it's red. So you can get 1, a 2, a 3, a 4, a 5, and a 6. Over here in the green die, you'd get a 1, 2, a 3, a 4, a 5, and a 6. Now there's a couple ways you can look at this. You can write this as a 1, 1, or a total of 2, a 1, 2, or a total of 3, a 1, 3, or a total of 4. We'll put the totals in the center part because you can tell if you get a 1 and a 1 green and 1 on red, that they're going to be different. But we'll put the totals in the center part because we often talk about the totals. So this is a total of 2, 3, 4, 5, 6, 7. Then you got 3, 4, 5, 6, 7, and 8. And we keep going. 4, 5, 6, 7, 8, 9. Then we get 5, 6, 7, 8, 9, 10. We get 6, 7, 8, 9, 10, and 11. And then we've got 7, 8, 9, 10, 11, and 12. Okay, so this is the grid that we'll be looking at. When we're talking about totals, that's these black numbers. When we're talking about rolling the die, what's the probability of rolling 5 on the red and 3 on the green? Well, that's only one probability. This one here, getting that one and that one would be 8 out of the 36. But often they talk about totals. Okay, and like I said, this video is going to be a little bit longer because I'm not going to give you a bunch of practice from the book because the book doesn't really cover this at all. I might just give you a sheet of practice or something like that if we get a chance. Okay, so let's take a look at types of questions now. Keep this available to do some counting on. I usually just make one and put it off to the side for myself. Okay, and again, don't worry about the chats coming in. It's just our people working. Okay, I need to maybe turn that down here. Let's see if I can do that. Okay, let's see what happens. Okay, so let's do some examples. Okay, so what is the probability we're talking theoretical probability of rolling doubles on 2 6-sided die? Okay, so favorable over total. The total obviously is 36. This is 6 by 6. So it's going to be out of 36 every time. So probability is going to equal the favorable over the total. Okay, so if we're going to do favorable, I'm going to underline them here. Doubles. 1 and 1, that's a double. 2 and 2, that's a double. 3 and 3, this is a double. 4 and 4, that's a double. 5 and 5, that's a double. 6 and 6, this is a double. So what do we got? We got 1, 2, 3, 4, 5, 6 out of 36. Okay, over 1 over 6 if we divide the 6 out. And if we go 6 over 36 to get a percentage, we get 0.167 or 16.7%. Okay. Okay. That's for that. Let's do another one. Let's do what is the probability of rolling what is the probability of rolling doubles or remember with or you don't want to count them twice a total over 10 or over 10, we'll say over 10. So this is a tricky one. So we've got our doubles underlined already. Now we just need totals over 10. Well, if we look at our chart, 10's not over 10. It's equal to 10. So we've got to add in here those two. We don't want to count these twice, so we just add that one and add that one. We don't want to count that one twice. That's over 10, but we already counted it in doubles. So now what do we have? 6, 7, 8. We have 8 out of 36. So our probability is the favorable over the total. If you like, we could even cut it down to just letters. 8 over 36. Okay, we could get that down by dividing by 2, 4 over 18, or dividing by 4, 2 over 9. If you want to reduce it, but you can just divide 8 divided by 36 to get our decimal. 0.22222. So 0.222 or 22.2%. Okay, let's do one more. Okay, I'm just going to erase the purple now so that we can use this chart again. Okay, so what if I said, all right, so we got a clean chart that we're going to use, and try this one if you like. Let's try, what is the probability of rolling a 7, a total of 7, or a total of 11 on 2 6-sided die. it a try, and we'll work it out right away. You just pause the video and give it a try, and then we'll work it out on the chart. Okay, so if we're doing that, a total of 7 or an 11. So we have to underline our 7 and 11s. So our 7 is 1, 2, 3, 4, 5, 6, 7, 8. So we're going to get 8 out of 11, or 8 out of 36 again. Eight of 36, which we already did the decimals for. So we know that's 22.2%. Okay, so that's theoretical probability. Theoretical probability is the favorable events over the total number of events in for an event. Remember, experimental is totally different. That's where you're actually doing tests. And that's what we did yesterday. You did a bunch of tests to see how close you could get to the theoretical probability. Okay, so we've used up about 37 minutes here. So what I'm going to do, I guess, is I'm going to give you a couple of practice ones on a Google Doc because there's none in the book, and then I'll just put the answers on the bottom of it for you to check. I won't give you a whole bunch because we spent a lot of time on video today, but I'll make a few on a Google Doc and put it up because the book doesn't really do a good job of it. All right, and then you can just do them. It'll take you 5 minutes. It's not a very tough area to worry about. Okay, and we'll be working on some more probability stuff tomorrow.